There's our basics. There's the main things that we got when we're going into this part. And again, less than, greater than, it's an open circle. If you put the bar underneath it to make it equal to, you make it a solid circle when you graph it. And again, as long as you put the X first, this arrow that's here will always match up with the arrow that you have to shade that would go there. Same thing here. This less than would have it going that way. All right, so that's the basics of the things that we were doing kind of back then. Here's something new we're going to add in that now you may not see a lot of it when we're working through the homework just yet, but when we get a little bit farther down the road, we're going to do this. So we're going to go ahead and mention it now, just because it's always good to kind of mention it a couple of times before we get to the real part of it when we look at it later. But what we're going to look at is interval notation. And sometimes we'll do that, but just so we can do it short, sometimes we'll just put I in just to make it go a little bit quicker when we're working through the answers on these. All right, and here's basically what it is. Interval notation, because right now we're just graphing, this is like graphing number lines. Obviously, pretty soon we're going to get to where we're back to graphing X's and Y's, and we've got curves and, you know, all kinds of different shapes of graphs that we're going to do. So we're not going to be looking at just a straight number line. So eventually this graph is not going to work. We're going to have graphs that have like curves all over the place. And this is kind of getting us ready for that part of it. Interval notation basically does this. It takes the answer that we have of a graph, so it takes the answer from graph form, and we're going to rewrite it using, and here's where we're going to take these graphs we have up here and kind of replace it with something else to make it a little bit easier when we start doing graphs that aren't just a regular number line. If it was all number line, we wouldn't have to worry about doing interval notation because it's already there. But eventually we're going to get away from the number line and have it so we have the Y values in there also. And it's going to kind of need a little bit to go with this one. So here's what we're going to do. We're going to use parentheses instead of an open circle. We're going to use square brackets instead of a solid circle. Okay, and really those are the two main things that we have to do. Now, a couple other little just details we got to make sure that we do this, and this is stuff that I've kind of added in over the years as we've gone through and done this lesson more, kind of realized some things. If we back up for just a second, let me kind of go back up to these graphs up here. And here's kind of what you got to think about. This graph starts at 4 and heads off to the right side. Is there a biggest number that ever, if you keep going to the right side, is there a max number that you can get to? There's not, right? You can go forever and ever and ever and ever. So if we were going on this part, this would go to infinity, right? Same thing on this graph. It keeps getting smaller and smaller. The number keeps getting to be lesser. So this one, same thing, but it would go to negative infinity. So when we start talking about these graphs, that's something you have to realize that we're going to talk about in some cases, because we'll go forever. We may talk about infinity or negative infinity. So when you use negative infinity or infinity, they will always use parentheses. Regardless of whether the circle was solid or open or not, doesn't matter. Anytime you're going to talk about infinity or negative infinity, you're always going to use parentheses. And then the last little thing we'll look at, and again, just something I've kind of added in over the years, you always have to make sure that your lowest number is on the left. So I remember doing this the first few times doing this, and sometimes people would have the right numbers, but they would have them in the wrong spot. They'd put their lowest number on the right side and their bigger number would be on the left. And I was like, well, okay, that's correct, but you've got the order wrong. So you've got to still kind of think about it being like number line, that, anytime you do a number line, the smaller numbers on the left, the bigger numbers on the right side on this one. So same thing when we talk about these, it's going to basically be the same thing. Okay, so let's do this. Let me show you. We're going to start with an inequality. We'll do just a quick sketch of the graph of it, and then we'll show you, okay, if this is the inequality we have or this is the graph we have, if we have either one of these two things, if they ask for interval notation, this is what the answer would look like. All right, graph-wise on this one. 6, 7, 8. Graph should be pretty straightforward there. Open circle at 7. And again, that arrow will match with this arrow, so it's headed off to the left. Okay, in interval notation, basically, it's going to tell you, all right, you tell me what's the smallest number that I can use on this graph, and tell me what's the biggest number I can use on this graph. So for this one, again, the smallest number would be negative infinity. And we'll put a parentheses there. And then you put a comma, and then you tell me, all right, the biggest number then is 7. It had an open circle on it, so then that would be a parentheses as well. And so all three of these basically say the same thing. It's just a different way of looking at it. This is it in inequality form. This is basically from a graph, and this would be what they call interval notation. And sometimes people go, well, interval notation looks a lot like an ordered pair. And I'm like, it does. And with that one, again, it's always the first number, which is your lowest number on the left, and then the bigger number will be on the right. So, all right, and then one more over here. Let's do x greater than or equal to negative 10. Okay, graph-wise. Negative 10, negative 9, negative 11. This time we'll have a solid circle at the negative 10. And again, arrows pointed to the right side, so we need an arrow that will point to the right side. Okay, in interval notation, again, you basically give me two numbers. Biggest number on the right side, small number on the left-hand side, and then depending on what the numbers are and what you have there, it's a solid circle, so that one you'll put the square bracket around it. And again, infinity, it doesn't matter what this circle is, you never can get to infinity, so that one will always have a parentheses. You give me a number, I'll give you a number that's a little bit bigger. I can give you a number, you can give me a number that's bigger. So no matter what we do, we keep playing it so that you can get a bigger number. So it's almost like there's an open circle at infinity, because you can't tell me what infinity is, so we just keep going forever there. Okay. All right, so that's the basics on everything. That's interval notation. Again, you won't see anything homework-wise about interval notation just yet. That's something that's coming a little bit down the road, so we'll go ahead and throw it out to you now, just so that the more times you see it now, the easier it is when we actually start doing this a little bit later on. So what we're going to do, we're going to do just a few problems here where we're going to solve them and graph them, and also write an interval notation. So we'll solve it, we'll graph it, and then at the end, we're going to take and write that answer in interval notation form. Okay, and that'll be the directions for, we'll do like 3 examples here just to make sure that you got it. And same directions in all 3 of these when we go through this part. All right, first one, let's go with 8x minus 15 less than 73. So whether it's equation or inequality, doesn't matter. You still solve it the same way. It's 8x minus 15. So we'll still add 15 to both sides. So you get down to 8x less than 88. And then from there, one last step, we'll go back and divide both sides by 8. So x less than 11. Yeah, we'll come to that one here in just a minute. So we'll go back and remind you that one time when you flip the signs. Okay, so solving it. There we go. We've got it solved. That's the first answer you'd see solving it. Graph-wise, again, not too difficult. Hopefully everybody's go back and remember those. 10, 11, 12. We need an open circle at 11. Arrows pointing to the left, so we need this on the left-hand side. And then we shade it in from there to there. Okay, and homework you'll see now, that's the only two things you're going to ask. We're doing interval notation just so that, again, y'all are practicing with it so you see it when we get there. Interval notation form. Again, it's going to the left, so that's negative infinity. We're going to get to 11, and since it's an open circle, we'll put a parentheses there. Okay, let's give you another one here. Make this one a little bit longer. Okay, and just like when we were doing the equations last week, and we said that, you know, if you have an equation, you can worry about the left-hand side and you work it out, and then you worry about the right-hand side and you work it out, and you get to the end, and then you compare and kind of go from those. So this one's still pretty much the same thing. Before we worry about anything with the less than part here, we're going to just go through and work out everything that's on the left-hand side of this inequality. So first thing is we'll do -3 times both of these. So it's -6x plus 15. The plus one, we didn't do anything with it yet because it was just hanging off on the end. Now we can go back and add those two pieces together. So we get -6x plus 16. Okay, there's nothing else you can do there, so now we can bring in the less than 4. There's nothing on the right-hand side, so basically here we're just going ahead and just solving this thing out for the rest of the way. Subtract 16 from both sides. Got -6x is less than or equal to -12. And then once we're here, we're going to divide both sides by -6. Okay, so left-hand side, we'll get the x. Negative by negative makes that a 2. All right, here's the catch. Here's the one time, kind of going back to the question over here. There's one time you have to worry about flipping your inequality signs. And this is that spot. So if you multiply or divide, here's the key part of it. Both sides by negative, you have to change your less than greater than sign. So as soon as we divide by the -6 here, this part that was a less than. If we change this sign and we change this sign, you also have to change this sign because everything has been flipped around. So we've also got to go back and do that. Okay, and that's the only time you really do anything different from equations to inequalities. So, if it's less than, if it's greater than, doesn't really matter. And some people will kind of go back and say, well, what about the beginning back here when we multiplied by -3? Well, we only did it on the left-hand side because we kind of had this block here kind of blocking this thing off. If you only do it on this one side, you don't worry about changing the inequality sign. So even though we multiply by -3 here, doesn't matter. It's only when you do it on both sides and this number is negative that you go back and flip this inequality. Okay, so graph-wise on this one, we're greater than or equal to 2. So a solid circle at 2 is off to the right. Okay, and then last thing here for interval notation, we've got a solid circle at 2. So that's a square bracket at 2. It's headed off to the right side. So that would go out to infinity. Okay, now, and I don't think this will happen, but just in case, let me show you one little something here, because every now and again, can't control every single problem that pops up, but just in case you get this one, and this is just a really short one here, I only go to the next page. If you do happen to get a problem that's, because every now and again somebody will run across this problem, and again, it doesn't happen a lot, but just in case this does happen. Let's say you have 8x less than 4. Only one thing to do in this case. A lot of people go, oh, well, that's 2. Not exactly, because again, if you divide by 8, now you've got x is less than 4/8. If you simplify that down, that's going to be a half. And sometimes people go, well, how are we going to put a half? Again, the good news is when you're doing these problems that it should be that they've already got the choices for you. And more than likely, they'll have something like this where you'll see, all right, well, half will be somewhere between 0 and 1. And you should have an open circle somewhere between 0 and 1 and head it off this way. Something like that. They might even go back and put a little mark in the halfway mark of it to let you know that that's where a half would be. But if you do get a fraction, it should fall in between the two whole numbers. I mean, that's probably worst case scenario. I don't know that that's going to happen a lot, but I'm not able to control every single problem that pops up. But just in case you do get a fraction, it would look something kind of like that. Okay, so there's the basics of everything we're kind of talking about. Just, and again, the only real thing to worry about when we're doing inequalities is if you have a negative number that you multiply or divide by, you have to flip it. Again, just to make sure you've got that. If it was 4x greater than -20, you wouldn't have to do anything on this one because you're going to divide both sides by 4. Because sometimes people go, well, that number is negative, so I've got to flip the sign. No. It basically comes down to if you get to the end and you're doing multiplication or division, if the number with the x is negative, that's when you got to flip the sign. It doesn't matter about this number that's over here. It's only if this number is negative that you've got to flip your inequality sign. Because if this is 4x, you divide both sides by 4, you're dividing by a positive, you don't flip the sign. Where if this was a -4, then you're dividing by -4, then you do have to go back and flip that inequality sign. Okay, so that's the basics of everything we're kind of going on to. Here's where we're going to go back and pick up what we did on Friday or Monday, whenever it was I saw you last when we were talking about this, when we're doing equations. This is where we were doing it last week, and then actually hopefully make a little bit more sense today. This is where we had to do something that was always, sometimes, or never true. Okay, and there's really only 2 steps to this thing. Step 1 is you're going to solve the inequality. Yeah. So it doesn't matter if it was just a regular question or it says, is this always, sometimes, or never true? And then they give you inequality. It doesn't matter what they do. If they give you inequality, you've got to solve it, regardless of what's happening. Okay, after you've solved the inequality, then you basically have 3 options. And you can kind of split it up into 2 parts. So we'll do like here's a step 2A, and then we've got one part that's here, and we'll kind of go with the rest of it. For 2A, we'll say it this way. If you have a variable in your answer, so if you have x is greater than 2, or y is less than 3, or t is less than or equal to 0, it doesn't matter what it is. If you've got a variable that's left over in your answer, it is sometimes true. And to me, this is the one that makes a lot of sense. That it's easier almost to talk about the inequality part than it is the equations. Because when we're doing the equations, it was, x equals 2 or y equals 3. And people are like, well, then it's always true for that number. It is. This one's a lot easier to see because any number that's greater than 2, this thing will be true. Any number that's less than 2, it's going to be false. So it's kind of a 50-50 kind of thing. So if some answers work and some answers don't, then that means it's got to be sometimes true. So if you have a variable in your answer, it's going to be sometimes true. All right. And then if there is no variable, well, then we've got a couple options we get from this thing. So if there is no variable and the inequality is true, which means it makes sense. This would be where you get like 0 is less than 10. Or you get 4 is greater than -2. You look at it and go, well, yeah, that makes sense. 4 is greater than -2. 0 is less than 10. You get something that when you look at it, you go, well, yeah, that makes sense. Then it's always true. Okay, and then the other option, if you remember back a couple of days ago, well, if we've taken care of the always, we've taken care of the sometimes, the only way for it to be never true is that the inequality is false, which means it doesn't make sense. This is where you would have, 5 is greater than 4. Or sorry, 5 is greater than 14. No, 5 is less than 14. Or you get 0 is 0 is less than -7. No, 0 is greater than -7. Now, and it could even be that you get one like this where you've got like 8 is less than 8. Because sometimes it throws people off if you got the same number and you're like, well, no, 8 is not less than 8. You're like, okay. Now, one that you can kind of put back up here where it's always true, you could have like 8 is less than or equal to 8. Sometimes that one will throw people off because they're like, well, 8 is not less than 8. Well, that's true. You know, because eight is not less than 8. That's definitely a false statement. But because of the equal part, you've got to include that one because 8 is not less than 8, but 8 is equal to 8. So this part isn't true, but this part is true every single time. 8 is always equal to 8. So if you have one like that, that's always true. If you have this, then this would be never true. Okay, so it still kind of follows the same thing we did with equations because equations, we said if you get x in the answer, if you get the variable answer, it's sometimes true. This one is basically the same thing. You know, if you look at it and it makes sense, then it's always true. If there's no variables, if it doesn't make any sense, then it's never true. So it's still following along those same patterns. It's just now it's less thans and greater thans instead of equal tos that we were doing a few days ago. Okay, now if we've got, and we may not have time, so we'll, again, they would give you a problem, you know, kind of like the ones we had back here, and they would ask you to, you know, solve this equation and tell them if it's always, sometimes, or never true. If we'd gotten here to this point where we had this, then this answer would have been sometimes true. So as long as you get x in the answer, then you know it's going to be sometimes true. If we'd gotten to the end here and this had been like 0 equals 2, is 0 greater than or equal to 2, then that would have been never true. That kind of thing. So you just get to the end, you look at the answer, and again, if you have an x, it's sometimes true. If there is no x, it's either never true or it's always true, just depending on the numbers you've got left over and how they compare. Okay. All right, now here's where we're going to go back again to something that you did probably a couple of years ago. I don't think y'all did this in geometry because geometry was more worried about circles and triangles and shapes and arcs and all those things. And you just didn't quite run into this in geometry. It's more of something you would have seen back in Algebra 1. This is where we're going to do, we're going to solve and graph compound inequalities. And hopefully you remember this one, that there were two main types. You had the and statements, which they like to say this was the intersection, which is basically what they both have in common. Or you have the or statement, which is what they call the union, which was basically what was covered by either graph. So the and was a little bit more difficult because you have to kind of put the pieces together and figure out what they over. It's almost like you have to lay them on top of each other. That if you had one that was yellow and the other one was blue, if you put the yellow and blue graphs on top of each other, wherever they have where you get a green, that would be your answer that you're looking for, kind of thing. The or was easier because you just graph it, whatever shows up, that's your answer. You don't have to worry about comparing anything. You don't have to worry about anything like that that comes off of it. A good way of thinking about this one is, if I ask you, all right, tell me what's at the corner of Jeff Road and 72. Well, it's either Mapco, the Marathon gas station, you got Texas Roadhouse, and on the other corner you've got like Stakeout and Broken Egg Cafe, something like that that's there. Where if I said, all right, tell me something that's on Jeff Road or 72. Well, now you just open up a whole big can of worms, right? Because now we got everything on Jeff Road, you've got everything on 72. So you can name anything and all that's there, and that's the correct answer. Where if you do and, it has to be what's just at that one little spot where they cross over each other. So that's kind of the thought process when you're seeing this one, is that's what you've got to think about is, and's what they both have, and or is anything that's on any graph at all that you can have that's anywhere covered at any point in time for this thing. All right, so we'll go through a couple examples here and show you what we're looking at. So let's go with 2x plus 4 is greater than negative 12, and 9x is less than 18. So with the and part we have here, we're looking for the intersection. We're looking for what they both have in common. Okay, if they give you an and statement, again, we'll do it kind of like we're doing before. We're going to worry about this one inequality, we'll solve it, then we'll come back and worry about this inequality and solve it, and then at the end, we'll put the two answers together to see what we can get out of it. So for the one on the left, we'll subtract 4. And once we're here, we'll divide by 2. Okay, and again, we don't have to flip this inequality sign because, yes, the 16 is negative, but this 2 is not, so we're dividing it by a positive 2. And as long as we divide by positive, we don't have to flip the inequality sign. All right, right side, it's a lot easier to solve it. We just divide both sides by 9. So that's x less than 2. Okay, graph-wise, when you do these, and again, this is where we have to kind of look at the two graphs kind of separate and then put them together. So if we kind of do these two graphs separately, we'll kind of like stack them on top of each other. We'll put a -8 here. We'll put the 2 here. We're going to graph x is greater than -8 on the top, and on the bottom, we're going to graph x is less than 2. Okay, so on the top part, if we do everything greater than 8, that's an open circle here and off in that direction. And if we do x is less than 2 on the bottom, that's another open circle here, and that one's headed in that direction. Okay, so the part that they overlap, that they share the part in common, that's basically everything in the middle. That's all this stuff that's in here. So the final answer that you get for this thing on your graph is going to be basically that we're going to go from -8 to 2, and we're going to put an open circle at the -8, and we're going to put an open circle at 2, and we're going to shade in everything in between those two numbers. Okay, now, and here's one where you actually kind of, you need the graph to go back and get the answer, because if you're going through and picking out problems in the homework, you're not going to see this answer. Because you look for it and you're like, hey, where did my, because the and is gone on this thing. What they're going to do, and here's kind of where the mentality you have to kind of think about on this one is that if we had this one in interval notation, that this would be everything from -8 to 2. And so the final answer that they're going to have is they're going to say, well, that means x is sandwiched between these two numbers. So this answer that you have that's here is basically this, is they're going to take these two numbers you have here at -8 and 2, and they're going to put x in the middle of it. And if you notice on this one, we've got x is less than 2. And if we reverse the order around on these, and this is something you can kind of notice too, this arrow is pointed at the -8. We need this one to point at the -8. So we reverse the order here, so we got to reverse the order here to kind of put it back in the middle on this thing. So this would actually be the answer that you would see for your options in the book there. And so here's something that I kind of figured out when I was going through these and kind of making this thing work out. That when you have and graphs, now again, this is kind of a, you may laugh a little bit, but that's okay. As long as you make it, as long as you remembered it, I'm fine with it. And graphs Usually, now that's the key word, usually, because there's always sometimes you get a weird graph that doesn't quite look like it should and something weird happens to it. But most of the time, and graphs usually are, here's where we kind of put it together, sandwiched, because we got the and the sandwich there, because and's inside sandwich. So and graphs are usually sandwiched between two numbers. Now again, sometimes you'll get a weird graph and they don't quite work out that way, and we'll show you one at the end where that might happen. But generally speaking, that's what they look like. And graphs are usually sandwiched between two numbers when you get finished with this thing. I always like that word association. That and is sandwiched. It's sandwiched together because it's all kind of stuck in the middle of that thing. So when you're doing these, you won't see this type of answer with the and in here. They'll actually go back and rewrite it so it looks something like that. Okay, so there's an and graph. There's what it looks like when we get finished with it. There's the whole thought process of going through this thing. Let's show you an OR graph. And then after we do that one with the OR graph, everything else is just trick questions. And I'll show you a few trick questions that may pop up when you're going through these. and we'll make those really short and easy so you can do it in a hurry and not have to worry about taking too long to go through these. All right, so let's go with 4 times x plus 3 less than 16, or negative 12x less than or equal to negative 144. Okay, so again, one piece at a time. We'll worry about this one on the left, and we'll come back and get the part of it on right here. So first thing is we'll do distributive properties. So make it 4x plus 12 less than 16. Subtract the 12. And then we'll divide by the 4. We got x is less than 1. Okay, right hand side. Not a lot to do on this one. We just got to divide both sides by negative 12. But main thing on this is just, again, if we're dividing it by a negative number, we're going to get the x here. You've got to flip this inequality sign around and make it greater than. And then whatever the number is here, then that's what we work it out to be. Okay, so there's our 2 OR statements. It's either x is less than 1 or it's x is greater than or equal to negative 12. And again, to me, the OR graphs are a lot easier because on the OR graphs, you don't have to worry about stacking anything on here. You put the smaller number on the left, you put the bigger number on the right, you graph it, and whatever you get, that is your answer. So I always love doing OR graphs because it was a whole lot easier than the AND graphs. Because AND graph, you had to go back and compare it and see what they had, and stack them up. So. All right, so less than 1, greater than 12. Okay, there you go. What you get's what you get. Okay, now if you did do interval notation on this one, again, this is, you don't have to do it in homework, but we're just showing you this part of it to get here. Some people are like, well, what are we doing? A 2-part graph? Well, basically, you do it just like one piece at a time. You would do just like you were going to graph this one. This part would go from negative infinity up to 1. If you do this part of the graph, it's going to start at 12. It's going to go to infinity. And like, well, what about in the middle? Well, in the middle, since it's a union, we talked about it back then, they actually just put a U in there, that U stands for union. And here's kind of the way I always think about with OR statements. And if you laugh at this, that's fine because I'm a terrible artist. I know it. I always thought about or statements that to me it kind of looked like oars on a boat. If I would kind of pretend like this was a boat, here's a guy or girl inside of it, and they're reaching out over here to get the oars, and then they're getting ready to oar, and they're getting ready to paddle on this thing. So whenever I see an or statement, to me, that or statement looks like oars on a boat. Not or statements, or graphs, sorry. All right. Again, the keyword there usually, because sometimes we'll show you something here in a minute where they're not this way. But or graphs usually look like oars on a boat to me. Now, if you don't see it, that's fine. But when I see the things on the outside, because when you think about when the oars are, they're always on the outside. They're in the water, they're paddling, they're pushing this thing down. So this is one where they're in a race, they're getting ready, they gotta have the oars out of the water, and now they're getting ready to kind of go back and put this thing in here. So that's kind of the way I always thought about it. That's my boat, and there's my oars on the outside, and I'm getting ready to paddle this thing. So and statements, most of the time it's everything between these 2 points. Or statements, it's kind of the opposite. It's everything on the outside of those 2 points. It's just kind of getting those 2 things to kind of think about there. All right, now here's all the, now again, that's the way they're going to look most of the time in most normal situations. Let me just throw you some quick what if kind of trick questions here. And I don't really call them trick graphs, but they're unusual graphs. They're not like your normal pattern of things when you go through and do these. These are just those weird graphs that kind of pop up, and sometimes it throws people off a little bit, but we'll give it to you here. All right, again, we'll say that we've solved this thing and we've got it down to these 2. We're going to skip over the solving part and just get down to the main part of the graph here. Okay, so there's the 1 and the 6. We need everything that's greater than 1 or equal to 1. So that's a solid circle here going this way. Or we need everything that is less than 6. So that's an open circle here going that way. Okay, here's what makes this one tricky. If it's an or statement, anything on the graph is what we want. Well, you graph these 2 and we've covered the whole graph, right? So if the whole graph is covered in an or statement, the answer is always true. Or sometimes instead of saying always true, they may go back and say that this thing has all real numbers. And if you think about it, it'll fit no matter what you do. Tell me a number that's bigger than 1 or a number that's less than 6. Any number you pick is going to be bigger than 1 or less than 6. If you pick -4, it's like, well, -4 is not greater than 1, but -4 is less than -6. So any number you pick is going to fit in there. And that's why when you go back and do this, you cover the whole thing because the whole thing is covered when it comes off of it. Let's see. Let's something else we could do here. Give a trick and statement here. Let's do like x is less than 2 and x is greater than or equal to 4. Okay, and again with the and statements, this is the one that you kind of have to stack them on top of each other. So if we do x is less than 2 over here, that's an open circle headed that way. And if you do x is greater than or equal to 4, that's a solid circle over here headed that way. And you go up, they don't overlap each other, right? So if it's no overlap, that means there's no solution. Okay. And if there's not an overlap, that means that it's an empty graph. So this would be one the answer would just be a blank graph. If there is no overlap, then there is no graph at all in this thing because there's no solution. There is not an answer that you can put on here that would fit into both of those categories. Okay, and then the last couple of little trick questions that they might throw at you. If we turn one of these around, so we had x greater than 2 and x greater than or equal to 4. Yep, we just got to stack them on top of each other. Everything greater than 2, again, you don't have to be super detailed on these because we're just kind of giving you the trick questions that pop up here, would be this one. And x is greater than or equal to 4, that's going to start here and then go that way. Well, the overlap is going to be everything here, right? Going out forever. So this is one where it's not going to be sandwiched between two numbers. I mean, I guess you could say it's sandwiched between two numbers. This time it's going to be sandwiched between 4 and infinity, right? Because this is the common part we've got here where they're both graphed. So your final graph on this one would just start at 4 and then go out to infinity. Because that's where you would kind of go for that part. Which means that if this was your final answer, it would just be x greater than or equal to 4. You wouldn't actually have to do an and statement on that one because you don't need both of them. You would just need the one part that would be there. Okay. And the OR graph would basically be similar. The only difference is if we had, if we scratched this out and made this an OR statement, well, you wouldn't need this part of the graph because the x greater than 2 covers this one up. So if this was an OR statement, you would just have x greater than 2. So the AND statement, you would need just the smaller piece. If it's an OR statement, you would need the one that covers the bigger piece of it when it comes off of it. So the AND and OR, when they're going in the same direction, they're close to the same answer. They're just a little different off depending on which one you get there.